I'm Darby Allen, first grade teacher at A.L. Watts Elementary School. Today I'm going to review with you from Unit 2 from our math curriculum. Let's get started. We're going to be talking about the number partners of 10 and understanding the equal sign. Let's review some of the vocabulary we learned during Unit 2. Doubles. That is an addition fact that has add-ins that are the same, such as 4 plus 4. You can see here there are other doubles facts listed. A number bond, that is a diagram with a total and two add-ins. In this number bond, 5 is the whole and the two parts are 3 and 2. A total is a number found as the result of adding. In this example, 2 plus 3 equals 5. 5 is our total. An equal sign. That is a symbol that means is the same as. 6 equals 6. 6 is equal to 6. We're also going to talk about is the same as. That indicates that quantities are equal to each other. Just like 2 hearts are equal to the 2 dots on a number cube. They're the same as. A number sentence. That is a sentence with symbols and numbers that compares two amounts as equal, less than, or greater than. We're going to talk more about number sentences. We're going to be talking today about some strategies to find number partners of 10. One of the strategies that we're going to use is rows of squares. We're going to also talk about a 10 frame. We're also going to be talking about the visual model. And we're going to be talking about how to use our number bonds. One of the first number partners of 10 strategies that we're going to use is rows of squares. If you notice in these rows of squares, we can count that each row has 10 squares. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that each of these are lined up and have the same amount. So each row of squares has 10 squares. We're going to talk more about that in just a minute. Let's look at these rows of squares. Let's look at the smiley face first. Okay, we just counted and we know that each row of squares has 10 squares. So let's look at the different ways that we can make 10. In this first row, we have one white square. We have it numbered here as 1. Okay, let's count how many gray squares we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that here we have 1 white square and 9 gray squares. We know that the numbers 1 and 9 show one way that we can make the number 10 because we have 10 total squares in that row of squares. We're going to represent this 1 from the 1 white square as one of the parts in our number sentence. And then we know that we have 9 gray squares, so we can represent that here, showing that 9 is the other part. So we know our total is 10, and our add-ins or our parts are 1 and 9. Let's go to the next row of squares. Let's look at this row of squares. Let's see how many white squares we have. We have them labeled so that they're easier to count. 1, 2. We have 2 white squares in this row. So let's see how many gray squares we have in this row. We know that our whole, the total number of squares we have, is going to be 10. Let's count how many gray squares we have here. 1, 2, 3, 4, 5, 6, 7, 8. So we can go ahead and move on because we know that we have 2 white squares. So we're going to write that number 2 in this place. We actually already had one of our parts given, which was 8. So it is going to be used in our next number sentence because this is our flip-flop fact is like what we call it in my classroom, also known as the commutative property, because those parts have just swapped places. We're still using our whole is 10, and then the parts in this one are 2 and 8. And then you can see that the 8 and the 2 swap places here. Let's move down to our next problem with the sunshine. Let's look at the white squares. We have 1, 2, 3 white squares. Now let's count how many gray squares we have. We have 1, 2, 3, 4, 5, 6, 7 gray squares. So let's think about this. We know that we have 10 squares total. So how many white squares did we say we had in this situation? We have 3 white squares. How many gray squares do we have? We have 7 gray squares. So we know that our whole on this row of squares is 10, and our parts, because we have 3 white squares, are 3, and we had 7 gray squares, so 7. And then we can write our addition sentence as 10 equals 3 plus 7. Remember, it doesn't matter where our parts or our whole come in our number sentence, as long as the whole is on the side of the equal sign by itself and that the parts are together. So it doesn't matter if the whole comes at the beginning or the end of the number sentence. They just have to be even. And we'll talk more about that as we review. The next problem we have is our row of squares with another row of 10, okay? And let's count our white squares beside the cloud. 1, 2, 3, 4. We have 4 white squares. Now let's count our gray squares. 1, 2, 3, 4, 5, 6. So on this row of squares, we have 4 white squares and 6 gray squares. So I know that my parts are 4 and 6, but my whole has not changed at all. It's stayed 10. Now, let's move down to our last row of squares, which is our lightning rod. Okay, let's count along to figure out how many white squares we have and how many gray squares. Let's count. We have 1, 2, 3, 4, 5 white squares. Let's count our gray squares. 1, 2, 3, 4, 5. This is very interesting. We have the same number as white squares and gray squares. I also notice that I only have one addition sentence written here. Can you think about why we might have only one addition sentence written? That's right, it's a doubles fact. So we only need to write the 5 in this first addition sentence, because if we did a flip-flop fact or use the commutative property, we could show that it's still going to be 5 plus 5 equals 10. Great job with this. Okay, so now if we look back through, we can notice that all of our number partners for 10 are shown here. So we know that the number partners for 10 are 1 and 9, 2 and 8, 3 and 7, 4 and 6, and 5, and 5. Okay, so we can also look and see when the rows are set up this way that the number increases by 1 on this side and decreases by 1 on this side. Great job using the strategy of using rows of squares. Now we're going to talk about using a 10 frame. I know you all have used these a lot in your classrooms. This is a great strategy for addition and subtraction. And today we're going to be using it for finding number partners of 10. The biggest thing to remember is when you have a 10 frame, there are 10 squares in a 10 frame. You can see where I have counted them. Let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 spaces in a 10 frame. So if a 10 frame is completely filled up with counters, we know that there are going to be 10 counters. So this is a great way to find number partners of 10. Let's look at using a number bond. In my classroom, we use this by saying this is the whole, the big square or circle that's by itself. That's our whole. Also, when we talked about our vocabulary at the beginning of the lesson, we talked about how that is also called the total. Okay? The smaller squares that are together, those are the parts. Okay? The two parts make up the whole. In addition sentence, these would also be the add-ins. We're going to refer to these as a whole and two parts. And we're going to use the number bond to help us find the number partners of 10. This is another strategy that you can use, not only in finding number partners of 10, but number partners of lots of other numbers. Let's look at our smiley face problem to begin with. Okay, so let's look at this one. I don't have anything in my 10 frame yet, and my number bond is empty except for the 10, which is my whole or my total. So I can look down here at this addition sentence below my smiley face problem and see that 10 is written as my whole, and I already have a part that I know. The part that I know, or the add-in that I know, in this addition sentence is 9. I can go ahead and write the 9 in my number bond to show that that's a part that I already know. I can also go ahead and fill in my 10 frame to show that I have 9 counters because I'm working on finding the number partners of 10 using 10 frames and number bonds. So I have my 9 counters to show that 9 is one of the parts I know. Now I need to find out what is the other part that is missing to help me find my number partner of 10. So this may be one that you already know, the other part that goes with the 9 to make 10, but in case you don't, this is a great way to show it. Okay, I've drawn in my missing part, and I see that I only had to draw in one additional counter. So this helps me know that 1 is the part that I didn't know that now I know. And so I can fill that in the number bond and in my addition sentence. I can also use the commutative property or my flip-flop fact to show that 10 equals 1 plus 9, but 10 can also equal 9 plus 1 because it doesn't matter how you write it, 1 and 9 together equal 10. So you can write it as 1 plus 9 or 9 plus 1. Great job on that. Let's look at our heart problem. Okay, I can look at this problem and see that I know the part I already know is going to be 8. The whole is 10. So I'm going to go ahead and fill in my number bond and draw 8 counters to show the part I know. So I have drawn my 8 counters to show that 8 is the part I know, and I've also written it in my number bond. Now I need to draw the remainder of the counters because remember, we know that one whole 10 frame filled in is 10. And since we're working on finding number partners of 10, we're looking to fill in that 10 frame completely. So I already have 8, so let's draw the rest of the counters I need to complete that 10 frame. I had to draw 2 more counters to show that I have a whole of 10. So how many more counters did I have to draw? Exactly. I drew 2 more counters. So now I can fill that in my number bond and my addition sentence. There's the 2 to show that I had 2 more. Now I can do my flip-flop fact. Let's think about it. I have 10 equals 2 plus 8. What would be my flip-flop fact or my commutative property where my add-ins or my parts have swapped places? That's right. 10 equals 8 plus 2. That's the other way that we can write it as an addition fact. Let's move down to our sunshine. Great job. We went ahead and showed that 7 was the part we knew, and so it's written in our number bond, and 7 counters are drawn here. Now, remember, I'm looking for number partners of 10, so I need to fill in that 10 frame completely. So let's draw the amount of counters that I need to make 10. Great. 3 more counters were drawn to complete my 10 frame. Okay, so I'm going to fill in my addition sentence and my number bond that I drew 3 more counters. Great job. Now that I know both of my parts and my whole, I can do my flip-flop fact. So 10 equals 3 plus 7 is the same as 10 equals 7 plus 3. Great job. Okay, let's move to our cloud problem. Okay, I have an empty 10 frame. Let's look at our addition sentence to see what our part we know is. What is the part we know in this addition sentence? That's right, 6. So I can go ahead and fill in 6 counters and fill in 6 as the part I know in my number bond. Great job. Now, I need to finish filling in my 10 frame. Let's draw the counters that we need to finish filling in our 10 frame. How many counters did I draw to finish filling in my 10 frame? That's right. I drew 4 more counters to finish filling in my 10 frame. So I know that the part I knew was 6, and now I know my other part, that 4 and 6 together equal 10. I've shown it in my 10 frame and on my number bond, and I've also written it as an addition sentence. Now I can show the commutative property or the flip-flop fact. There we go. 10 equals 4 plus 6 is the same as 10 equals 6 plus 4. Okay, we have one more 10 frame and number bond. Let's look at the lightning bolt. We are at the lightning bolt here, and we can see that the part we know is 5, as it's shown in the addition sentence. Let's go ahead and write that in our number bond and fill in 5 counters in our 10 frame. Great job. Okay, now I have to finish filling in that 10 frame, and I need to know how many counters do I need to draw to finish filling in that 10 frame. That's right. I need 5 more counters to finish filling in that 10 frame. I noticed something interesting here. The gray counters and the counters I've drawn are the same amount. This is where we find our doubles fact for 10, because 5 and 5 equal 10. So now I found the missing part. Great job. Okay, if I look back through here, at each of my number bonds, I can find all of the number partners for 10. So 10 is my whole, so my number partners are 1 and 9, or 9 and 1, 2 and 8, or 8 and 2, 3 and 7, or 7 and 3, 4 and 6, or 6 and 4, and then 5 and 5. Great job. Now, we're going to look at using a different strategy to find number partners of 10. This is a visual model. What you have to do is write your numbers from 0 to 10 straight across. And then you can connect your numbers to find the number partners of 10. We didn't use any of our other strategies to find 0 and 10, but they are still considered number partners. So we have 0 and 10, and you'll notice the red line that shows where these connect. Okay, then we move to the next, and we have 1 and 9 are our number partners. Then we move on to 2 and 8, and you can follow the line and see how they're connected. The next ones are 3 and 7. Great job. And then we have 4 and 6. that could also be written as 6 and 4, just as these others can be flipped as well. Then our last one, there's no line with it because it's our doubles fact. 5 and 5 together equal 10. Great job! This is a different way to use a strategy using the visual model to find out the number partners of 10. We're going to continue to talk about the equal sign. This is the equal sign. 3 triangles are equal to 3 triangles. That means they are equal to or the same as. Equals means is the same as. 5 cubes is the same as or equal to 2 plus 3 more cubes. Let's count the cubes together. 1, 2, 3, 4, 5. We counted on from 2 to 5, counting all of these cubes. So 5 is the same as 2 plus 3 or 3 plus 2. Let's look at these balance beams. Think about when you've been on a teeter-totter or a seesaw with a friend. If you weigh the same amount, both sides would be equal. We have 1, 2, 3, 4, 5 cubes stacked here, and we have 1, 2, 3, 1, 2, or 5 cubes stacked here. So both sides are equal. The teeter-totter, the balance beam, is flat, showing that it is equal. If we have 5 cubes on one side and 3 cubes on the other, that would make it not equal. This would be like if you got on a teeter-totter or a seesaw with a parent. Their side might be a little bit heavier, and so it would not be balanced and it would not be equal. We're going to be looking at using the equal sign to find out if our number sentences are true. In this practice, we're going to work on circling the number sentence that is true, but we're going to have to use a strategy to find if these number sentences are true. So we're going to start with 9 equals 2 plus 7. I've shown 9 cubes here to represent the 9, 2 cubes here to represent the 2, and 7 cubes here to represent the 7. I'm going to see if both sides are equal, if they're the same. I've counted my 9 cubes and circled my 9 because that was the last number counted. Here I've counted on from 2 and 7 more cubes, and that equals 9, the last number counted. So I can see that both sides of the equal sign, here is my equal sign, I can see that both sides of the equal sign equal 9. So that means that this number sentence is true because they are equal. Now, let's check our next sentence. We have 7 cubes here, 2 cubes here, and then it says 7 plus 2 equals 10. Here's my 10 cubes. Let's see if these are equal. I added up my cubes. The strategy I used was drawing cubes. And I know that 7 and 2 equals 9. I actually already knew this because I know that 2 plus 7 and 7 plus 2 are just flip-flop or commutative facts. So I know that it equals 9. Okay, then I drew my 10 cubes and see that that is 10. And I know that 9 and 10 are not the same, so they are not equal. So 7 plus 2 equals 10 is not true. My job in this problem was to circle the true number sentence. So 9 equals 2 plus 7 is true because I know that 9 does equal 2 plus 7, and I know that 7 plus 2 does not equal 10. Great job. Okay, now let's apply what we've learned. Let's look. We have a 10 frame, a number bond, and an addition sentence. I can look and see that the part I know in this number bond is 4. I'm going to go ahead and represent that 4 in my 10 frame by drawing 4 counters. I'm going to go ahead and fill it in my addition sentence as well, since that is the part I know. Now that I've filled in the part that I know, I've written it in my number bond and in my addition sentence. I'm going to find the number of counters it takes to fill up my 10 frame. I'm going to draw out my counters. Let's count how many counters it took to complete my 10 frame, because I'm looking for those number partners of 10, and I already had 4 counters. Let's count. 1, 2, 3, 4, 5, 6. So 6 is the other part. 6 and 4 are number partners. So I've shown it in my number bond and in my addition sentence. Now I know that I can write another addition fact to go with this 10 frame and number bond to show the number partners for 10. I've already shown that 10 equals 4 plus 6. So now I'm going to use that commutative property, or those flip-flop facts, to write 6 plus 4 equals 10. I can also write a subtraction sentence. It's very important to remember that in subtraction sentences, the whole number comes before the subtraction sign. In addition sentences, it's always by itself to show that the two parts equal that whole. But in a subtraction sentence, we're taking the numbers away from the whole. So we have to show the whole number comes at the beginning of the subtraction sentence or before the subtraction sign. Sometimes it could even be after the equal sign, as you'll see in just a minute. So I'm going to show my numbers 4 and 6 in the subtraction sentence. Notice I did not use other number partners of 10 because the numbers partners that we're talking about in this problem that we've represented in our 10 frame and on our number bond are 4 and 6. So since I have 10 minus 4 equals 6, in this problem, I'm going to need to flip-flop the parts, commutative property, moving the parts, in my next subtraction sentence. So my next subtraction sentence is going to say 10 minus 6 equals 4. It's very important to pay attention to that, where that equal sign is, and making sure that you've used your whole before the subtraction sign in a subtraction sentence and by itself in an addition sentence. You have a packet with some practice. These pages are included in your packet. With this one, you are going to work through the word problem. The word problem is included on the parent information page number 1. You are going to find the number partners of 10 with the number cards. You can cut these out and use these number cards to find the number partners. Be sure to write down the number partners you find on your response page. This is another practice. You are going to find the number partners of 10 using the number bonds. Use the back of this page if you need to write strategies to find the missing parts. Use all those strategies that you've learned in first grade to help you. Here, we're going to work on solving each of these problems. Think about what you learned about the equal sign. There's a parent information page number 2 that goes along with this to support you. The next practice page, you're going to be finding the number partners of 10 using the number bonds. Use the back of this page if you need to write strategies to find the missing part. Once you know both parts, complete the addition sentences. You did a great job reviewing the Unit 2 math skills today. Remember, the packets will in no way affect a student's grade, but they're a great way to practice those important first grade foundational skills. I hope everyone stays safe and healthy. Have a great day. Thank you.